The novel coronavirus is rapidly spreading around the globe. Those most severely affected are the immunocompromised patients. Based on the knowledge of me and my colleagues on innate and adaptive immune response to viruses, let's see how these viruses affect the immunocompromised. Hi, I'm Jalki and I'll be talking about the effect of viruses on organ transplant recipients. When infected with COVID-19, it eventually gave rise to pneumonia, and thus retrospective studies suggest that 60 to 80% of immunocompromised cases will develop pneumonia and 10 to 40% will die as a result. As coronavirus cells and T cells in the body comes into contact, the T cells becomes a prey to the coronavirus, hence explaining the widespread of the disease.
My name is Ruby and my article researched the H9N2 influenza virus. This virus is found in domestic chickens but sometimes gives rise to clinical respiratory diseases in humans. Quantity's team tested immunocompromised chickens and found that the viral RNA is only found in them. It was also concluded that the virus spreads more rapidly in the cell-mediated suppressed chickens. Hence, the cell-mediated response is crucial against the virus.
Hi, I'm Tilly and my article researched lupus patients and their increased susceptibility to COVID-19. Lupus is a chronic disease caused by the immune system attacking its own tissues. Systemic lupus patients are more susceptible to COVID-19, independent of their immunosuppressive medications. ACE2 enables the entry of the virus into the cell and is hypermethylated and overexpressed in lupus patients. Demethylation of interferon-regulated genes and cytokine genes may also instigate a cytokine storm and an excessive immune response to the virus. Thus, lupus patients are more susceptible to viral infections.
PIP3 adopted T-cell transfer research was conducted. Blood samples were collected from volunteers and virus-specific T-cells were collected and counted. 10 million VSTs were stimulated, stained, and enzyme-linked analysis was done to measure VST activity. VSTs were harvested and transferred back into patients. The results found that a response was made by VSTs, whilst lack of VST activity led to infections. While healthy patients controlled the virus, patients with lacking PIP3 T-cell activity developed pneumonia and needed longer treatment. After adoptive transfer, patients almost immediately went into remission with PIP3. These results demonstrate the relevance of virus-specific T-cells in antiviral activity. Thus, it was concluded that T-cell transfer for PIP3 is feasible and can help with antiviral activity. Thus, viral infection in an immunocompromised host has the ability to cause severe complications in the disease with comparison to a normal healthy population.